Right, we need to factorize the difference of two cubes here in front of us, and we proceed to present a solution to this problem, but in a step-by-step manner. But first, we note the fact that we study what we call the difference of two cubes. Right, the difference of two cubes. How do we study the difference of two cubes? Right, we know that if it happens that we have x cubed minus y cubed, if you cover the cubes, you're left with x minus y into, you square the x, you say x by minus y by negative, it becomes plus x, y, you square the y, like so. As a consequence, then, this is sort of the formula we use to factorize the difference of two cubes. So at this point, this becomes our x and this becomes our y. So that given this, we proceed as follows. Right, we then have here twice p plus q. We cube it, minus p minus q. We cube it. If we cover the cubes, we shall then have twice p plus q within parentheses, p minus q in parentheses. Then we square the first binomial expression. So we write 2p plus q. We square it. Next, we multiply this binomial by that binomial. We multiply it by -1. Then it becomes plus twice p plus q into p minus q. We square the very last binomial, obtaining p minus q squared. And we close that way. Right, we further analyze these in detail. Right, analyzing this in detail, we obtain the following. Let us distribute here and open up the parentheses. And we have 2p plus q minus p plus q. If you square this one, it becomes 4p squared plus 4pq plus q squared. We distribute here, you open up the parentheses, and we multiply using the FOIL method, 2p plus p. You get 2p squared. 2p by minus q is minus 2pq. Right, we have q by p, it becomes pq. We can write qp minus q squared. Right, we continue with the work. We square this one. It becomes p squared minus 2pq plus q squared, like so. Upon further examination, we obtain the following. Adding like terms together and grouping, we have 2p minus p, and 2p minus p gives us p. Right, q plus q gives us twice q into. We have 4p squared plus 2p squared, which is 6p squared, plus p squared, which is equal to 7p squared. We have 4pq minus 2pq, which is 2pq, plus 1pq, or plus pq, which is 3pq, minus 2pq. It is exactly a PQ, like so. We have Q squared minus Q squared, which is 0 plus Q squared. And we have the Q squared like so. Hence, we infer that if we have the following, right, if we have twice P plus Q cubed minus P minus Q cubed, this is exactly the same as P plus 2Q into 7P squared plus PQ plus Q squared, like so. Exactly like so. Right, so we continue. So we have solved this problem in detail, and we have reached, therefore, this is the answer to the question, and we are done solving this. But we got a comment on the sum of cubes as well. Right, so we are able to factorize the sum of two cubes. The sum of two cubes. How do we deal with this? So if you have the cubes, x cubed with y cubed, if you cover the cubes, then you'll have x plus y. Right, and then you have exactly x squared. You square the x, then you multiply x by y, multiply by negative, it becomes minus xy, we square the y. It becomes y squared, like so. Right. So we continue. We continue. Right, and then also you can recall from grade 10 things like the difference of two squares. What do we say about the difference of two squares? So in other words, if you have x squared minus y squared, it is x minus y into x plus y. Right. And yeah, we are done with this question. We've factorized it in detail. Thanks everybody for your time and attention, and goodbye to you.